Hello friend. Now today we are going to discuss the new topic of calculus. It is mean value theorem. Now in this chapter we study three types of mean value theorem. Now this is the first mean value theorem. It is called the Rolle's theorem, or it is called the Rolle's theorem. Now see what is the statement of Rolle's theorem. Let f(x) be a function defined on closed interval ab having these three conditions. See what is the statement of Rolle's theorem, or what is the statement of Rolle's theorem. If f(x) is a function defined on closed interval ab such that this function f(x) has three conditions. What is the first condition? This function f(x), it is continuous in the closed interval ab. This function f(x), it is differentiable in the open interval ab, and this is the third condition, f of a is equal to f of b. So see what are the conditions of Rolle's theorem. If f(x) is a function having these three conditions, and what are those conditions? Function should be continuous in the closed interval ab. Function, it should be differentiable in the open interval ab, and this is the third condition, f of a is equal to f of b. Then what is the statement of Rolle's theorem? This Rolle's theorem says that we can find at least one point c belongs to open interval ab such that f dash c equal to 0. This is the statement of Rolle's theorem. Now see how to represent this Rolle's theorem geometrically. See what is the meaning of this statement. First of all, take this statement. f(x) it is a function defined on the closed interval ab. See what is the meaning of this statement. f(x) it is a function defined on closed interval ab means this f(x) it is a function, that means we can draw the plot of, we can plot the graph of that function. What is f(x)? f(x) that is a given function. So function means we can plot the graph of that particular function. So f(x) it is a function defined in the closed interval ab means the graph of the function, it should be lies in between this a and b. This is the limitation of this graph. Graph or function, it is defined on the closed interval ab means this graph of the function, it should be lies in between a and b. This graph does not lie to this portion or this portion. f(x) it is the function defined on closed interval ab means the graph of that function, it should be lies in between this a and b. Now see what is the meaning of this first condition. Function, it should be continuous in the closed interval ab. Now function, it is continuous. Continuous function means there is no gap between the graph. Now see, this is called the discontinuous curve. Suppose if we take this curve, then this function or this curve, this is continuous at x equal to 1 suppose. There is a gap between this curve. So this is called the discontinuous curve, or this is called the discontinuous function. Function, it should be continuous in the closed interval ab. That means in between a and b there is no gap. So this is called a continuous curve. If we consider suppose this second graph, then again we observe that in between a and b there is no gap. So this is called the continuous graph. But if we take suppose this graph, then this is called a discontinuous graph. this function or this graph, this is continuous at this graph, it is discontinuous at x equal to 1. This is the not continuous graph. So continuous graph means there is no gap between A and B. Now what is this second condition? Fx, it should be differentiable in the open interval AB. Now see, this differentiability, this is related to smoothness of the graph. Differentiable function means graph, it should be smooth. Now suppose if we consider this function fx equal to mod x or y equal to mod x. Now y equal to mod x means y equal to x and y equal to minus x. Now if we draw the graph of this function, then this is the graph of that function. Y is equal to x means this is the graph of y equal to x, and y equal to minus x means this is the graph of y equal to minus x. So this total graph, this is the graph of y equal to mod x. Now this graph y equal to mod x, this graph, this is the continuous curve, but this is not differentiable at x equal to 0. Because at x equal to 0, we find that there is some sharp edge. If the edge is, suppose that is a sharp edge, that means we cannot plot the tangent at this point. Differentiable function means the graph, it should be smooth graph. Smooth graph means we can plot tangent to every point. If the graph is the sharp edge, if suppose there is a sharp end, or if suppose there is a sharp edge, that means we cannot plot the tangent at this point. So differentiability, it is related with the smoothness of the graph. If suppose there is a sharp edge or a sharp end, that means that is not the differentiable graph. Now see what is the third condition. The functional values f of a and f of b, they are equal at the end point. The functional values are equal at the extreme point, f of a equal to f of b. They are the same value. So this graph, it is again satisfied the third condition. This is suppose a, so this is the value of f of a. If you consider this point as a b, then this is the value of b. F of a, this is same as the f of b. For the second graph, again this condition it is satisfied. F of a, this is same as the value of f of b. So first of all, remember these three conditions of Rolle's theorem. Function, it is defined in the closed interval AB means this is the limitation of the graph. Graph, it should be lies in between A and B. The graph, it does not lie to this portion or this portion. The graph, it should be lies in between A and B. Now this function satisfied these three conditions. So what are those conditions? Function, it should be continuous in the closed interval. Continuous means there is no gap between the graph. This is called the discontinuous curve, because there is a gap between these two curves. Continuous graph means there is no gap between the curve. What is second condition? Function should be differentiable in the open interval AB. Differentiable means graph, it should be smooth graph in between A and B. There should not be sharp edge, because for the sharp edge we cannot plot the tangent at that particular point. So this is not differentiable graph. This is the differentiable graph because we can plot the tangent at every point. So function should be differentiable in between A and B. And what is the third condition? The functional value at A, f of A, it is same as f of B. So obviously these two graphs satisfied these three conditions. So what are those conditions? Function, it should be continuous. What is second condition? Function, it should be differentiable. Differentiable means graph, it should be a smooth graph. There is no sharp edge. And what is the third condition? Functional values are equal at the end point. F of A is same as f of B. Then what is the statement of Rolle's theorem? This Rolle's theorem says that we can find at least one point C in between A and B. We can find at least one point C such that differentiation at x equal to C, this should be 0. Now see what is the meaning of f dash. Differentiation, it is 0. Differentiation means it is the slope of the tangent. Slope of tangent, it is 0. Now slope of tangent, it is 0. It is possible only if the tangent, it should be parallel to x-axis. If the tangent, if it is parallel to x-axis, then and then we can say that the slope of the tangent, it is 0. Slope, it is 0 means there is no angle between this line and this x-axis. There is a 0 angle. So tan 0, it is 0. So f dash c equal to 0. F dash c, it is 0 means slope of tangent, it should be 0. And slope of tangent, it is 0 means that tangent, it should be parallel to x-axis. So this is that point x equal to c. Now for this curve, this is the tangent parallel to x-axis. So obviously slope of tangent, it should be 0. For this point, we can also plot this tangent. This is again parallel to x-axis. So for this graph, there are 2 points C1 and C2 at which we can say that slope of tangent, it is 0. So see, what is the statement of Rolle's theorem? If f(x), it is a function having these three conditions. So what are those conditions? Function, it should be continuous. Continuous means there is no gap. Differentiable means graph should be smooth graph. And what is the third condition? The functional value f of a and f of b, they are equal. If f(x) satisfied these three conditions, then our Rolle's theorem says that we can find at least one point C in between A and B. This is the point C which is in between A and B, such that differentiation at x equal to C, that is 0. Differentiation, that is 0 means slope of tangent, it should be 0. And slope of tangent, it should be 0 means that tangent, it should be parallel to x-axis. Now this is x-axis, so this is the tangent. This tangent, it is parallel to x-axis. So for this curve, we have found these 2 points, and for this curve, we have found just a single point. So first of all, remember the statement of Rolle's theorem. Three conditions of Rolle's theorem is function, it should be continuous, function, it should be differentiable in the open interval, and the functional values are equal. So first condition, it is about the continuity. Second condition, it is about the differentiability, and third condition, it is about the equality of the function. So remember these three conditions: continuity, differentiability, and equality. If f(x) satisfied these three conditions, so we can find this point C by solving this condition f dash c equal to 0, that is the statement of Rolle's theorem. So let us take some example on Rolle's theorem. Now this is the first example. Verify Rolle's theorem for the function f(x) equal to x square minus 1, and we are given the interval as close interval -1 to +1. So in solution, first of all, write down this function. Okay, let take f(x) equal to x square minus 1, and what is the given interval? Interval, it is given, that is the closed interval -1 to +1. Now see, the question is, we have to verify the Rolle's theorem for this function. Now verification of Rolle's theorem means we have to check all the three conditions of Rolle's theorem. So see what is the statement of Rolle's theorem. If f(x) it is a function defined on closed interval AB. Now we are given the closed interval as -1 to +1. So obviously A it is -1 and B it is 1. So see what is the statement of Rolle's theorem. If f(x) it is a function defined on closed interval AB such that we have to verify these three conditions. So what are those conditions? Function, it should be continuous in the closed interval. Function, it should be differentiable in the open interval, and the functional values are equal at the end point. First condition, it is about the continuity. Second condition, it is about the differentiability of the function, and third condition, it is about the equality. Continuity, differentiability and equality. So first of all, check this first condition, it is about the continuity. So write down this observation. So write down here, we observe that number one. Now see what is our observation. This given function, it is the polynomial function x square minus 1, that is called the polynomial function. Now first of all, remember this concept. Every polynomial function, that is always the continuous in the real line. Every polynomial function, that is always the continuous. Or we can check the continuity like this. Suppose if we consider this function as x square minus 1. Take any point. Suppose let us take x equal to suppose 2. At x equal to 2, what is the limit of function? Limit of function means put x equal to 2, 2 square 4 minus 1, this limit will be 3. What is the value of function at x equal to 2 means find out just f2. Put x equal to 2, 4 minus 1, so this is again 2. So limit of function, this is same as the value of function. So obviously this is the continuous function at x equal to 2. So we can check for the every point. Or we can say like this, okay, because this is the polynomial function, and we know that every polynomial function, that is always continuous for the real line. So just write down this concept directly. Write down, we observe that, what is the first observation? Fx is continuous in closed interval minus 1 to plus 1. So this is our first observation. Okay, how it is the continuous function? Because it is the polynomial function, and we know that every polynomial function, it is the continuous function. So by using this concept, we can write directly here, okay, fx, it is continuous in the closed interval minus 1 to plus 1. Now second condition, it is about the differentiability. Now see how to check the differentiability. Now suppose if we consider the function as x square, and consider suppose another function fx equal to suppose log x, and consider the interval minus 1 to plus 1. This middle point, suppose it is 0, this is minus 1 and this is plus 1. We have taken these two functions fx equal to x square, this is the first function, and consider another function fx equal to log x, and check the differentiability in the same interval minus 1 to plus 1. Now see how to check the differentiability. Differentiability means just find out its derivative. Derivative f dash x, derivative of x square, for this function it is 2x. And if we take suppose fx equal to log x, then what is its derivative? F dash x, it is 1 upon x. Now see what is the next step. What is the first step? This is the given function, and just find out the derivative. Now what is the next step? Let us put the values of x in between minus 1 to plus 1. We can take the values of x in between minus 1 to plus 1. So let us put this middle point x equal to 0. Or we can take this x equal to 0.1, 0.2 up to 0.9. Or we can take the negative value 0.1, minus 0.2, minus 0.3 and so on. Now if we take suppose this middle number x equal to 0, now put x equal to 0, then 2 into 0, it is 0. So it is some finite number. If we put x equal to 0 for this function, this derivative f dash x, it is 1 upon x. So let us put the values of x equal to 1 upon z, x equal to 0. So 1 upon 0 means it is infinity. Infinity means this derivative does not exist. Finite quantity means it is called the existable quantity. and infinity means derivative does not exist. So remember this concept. If the derivative of the function, if it exists, then the function, it is said to be a differentiable function. Here the derivative does not exist. So if the derivative of function, if this does not exist, then that function, it is not differentiable in that interval. So fx equal to x square, it is differentiable in the interval -1 to +1, but fx equal to log x, this is not differentiable in the same interval -1 to +1. So what is the meaning of differentiation? Differentiation means just find out its derivative and just put the values of x in between that particular interval. If you put x equal to 0 in between -1 to +1, we can take x equal to 0. If you put x equal to 0, then we find that this derivative does not exist. So if derivative does not exist, then that is called the not differentiable function. If the derivative, if it is exists, then the function, it is said to be a differentiable function. So how to check the differentiability? Differentiability means just find out its derivative. So write down the given function fx equal to x square minus 1, that is the given function. Just find out its derivative. Derivative will be 2x. Now if you put the values of x in between -1 to +1, put any value 0, 0.1, 0.2, 0.003 up to 0.9. If you put suppose the values of x in between -1 to +1, then we find that this derivative has some finite value. So if the derivative has finite value, then that is called the existable quantity. So right here, therefore, f dash x means derivative exists. Derivative exists means the function, it is called the differentiable function. So right here, therefore, fx is differentiable or derivable in open interval -1 to +1. So see how to check the differentiability condition. Differentiability means just find out its derivative and let us put the values of x in between that interval. If derivative exists, then the function, it is said to be a differentiable function. Now verify third condition. So number 3. So it is about the equality of functions. So write down the value for fa. A means the first point, which is -1. So put x equal to -1 in the given function. So -1 square, it is 1. So 1 minus 1, it is 0. Find out the next value fb. B means the last point, which is 1. Put x equal to 1 in the given function. 1 square, it is 1 minus 1. So obviously 1 minus 1, this is again 0. So we observe that the value of fa, it is 0 and the value of fb, it is again 0. So right here, therefore, the value of fa and the value of fb, they are the same. So see, this function fx satisfies all the 3 conditions of Rolle's theorem. What are those conditions? Function, it should be continuous, because this is the polynomial function and we know that every polynomial function, it is continuous. So we can write this is the continuous. How to check the differentiability condition? Differentiability condition means just find out its derivative and just put the values of x in between that interval. If derivative exists, then the function, it is said to be a differentiable function, and this is the third condition, that is the equality of the functional value. So obviously fx satisfied all the 3 conditions of Rolle's theorem. So right here, therefore fx satisfied all the conditions of Rolle's theorem. So fx satisfied all the 3 conditions of Rolle's theorem. That means we can apply the statement of Rolle's theorem. So right here, therefore, by Rolle's theorem, so what is the statement of Rolle's theorem? There exists C belongs to open interval -1 to +1 such that, what is the statement of Rolle's theorem, f dash c equal to 0. So by solving this condition f dash c equal to 0, we have to find out this point c, and it should be lies in between -1 to +1. So see, what is our f dash x? We have found this f dash x earlier, it is 2x. So how to write this f dash c? From f dash x, we write this f dash c. That means just put x equal to c in this f dash x. So what is the value of f dash c? F dash c, it should be 2c equal to 0, because what is f dash x? F dash x, it is 2x. So from f dash x, write this f dash c. So just put x equal to c, so 2c equal to 0. So what is the value of c? C equal to 0. And obviously this is the value in between -1 to +1. So we have found the value of c equal to 0, and that is obviously which is in between this -1 to +1. So we can say that this Rolle's theorem, it is verified. So remember the concept of this mean value theorem, which is the Rolle's theorem. What is the statement of Rolle's theorem? For Rolle's theorem, we require 3 conditions: continuity in the closed interval, differentiability in the open interval, and the functional values are equal at the end point. Continuity, differentiability, and equality. If f(x) satisfied all the 3 conditions of Rolle's theorem, that means we can apply the Rolle's theorem and easily we can find the value of c. So thank you for watching.